Okay guys, so this is another quick short lesson. This is going to be on the connective tissues, and this is for the lab exam, okay? So now, connective tissues are very different from epithelial tissues. When we were talking about epithelial tissues, it was all about the cells. We had a bunch of glue layer called the basement membrane, and then all we had was cells, and it was about how many rows of cells and what's the shape of the cells. Connective tissues hold the body together or connect it functionally. So the cells, although they're important, they're not the focus. Instead, the main thing about connective tissues is something called the matrix. The matrix of each of the connective tissues is different, and it's the matrix that does the job of the connecting. Now, what is in a matrix? A matrix is made of two different things. It's made of a ground substance, ground not as in ground up, but as in a base substance. And that base substance is colorless, it's viscous, which means it can be a thick fluid, but it can be everything from a thick fluid like plasma of blood or the liquid in lymph to a firm gel, as we're going to see in cartilage, all the way up to a hard, solid, concrete-like material that we would see in bone. So that's the ground substance of the matrix. And then in that ground substance are going to be the cells and protein fibers. The protein fibers are critically important to a connective tissue being able to hold you together. The three protein fibers you're going to see are collagen fibers. I like to think of these as molecular rope. And if you think about a rope, it's very strong, but it doesn't do a whole lot of stretching. The second fiber is elastin fiber, and you can tell from its name it's going to be springy and stretchy and elastic. So it's kind of like a molecular bungee cord. It's very stretchy, but it's not as strong as collagen. And then finally, reticular fibers are kind of like molecular packing peanuts. We wrap organs in them and we use them to fill spaces and we use them to build filters. So a good way to remember each of these are these big S words I put at the end. Collagen is strong, elastin is for stretch, and reticular fibers are for making a sieve. A sieve is a filter like you'd play with at the beach, and you'd let the water run through and you'd catch the stuff with the filter, okay? So the fibers, most of these fibers are going to be in all of our connective tissues. It's the ratios of these fibers that make a difference, and we'll see that as we go along, okay? How many fibers and what kind. All right, but the cells are still important. The cells in connective tissue are named a special way. They're made up of a prefix and a suffix. The prefix, which is the front part of the name, tells you which connective tissue the cell is from. And some of our prefixes are fibro, which means fibers, adipo, chondro, and osteo. And then the cell ending or suffix tells you what is that cell doing in regards to the matrix. What is it doing for the matrix? Our suffix examples are blasts, clasts, and sites. A blast is something that builds a part of the matrix, either the ground substance or the fibers. A clast destroys matrix. Now, why in the world would we want to destroy matrix? Well, sometimes you need to change the shape of it. We need to remodel it. We need to repair it. And so these cells are able to dissolve the matrix so it can be rebuilt. And finally, the last cell suffix is site, which just means that particular cell is living in the matrix. It's done building and breaking. It's just living there now, okay? So how do we combine these? Well, if I told you the name of a cell was a fibroblast, then from this setup, you could tell me that that cell is building fibers for the matrix. Okay? So we would have fibroblasts and fibrocytes, not so many fibroclasts. Okay? You will see chondroblasts, chondroclasts, and chondrocytes. You will see osteoblasts, osteoclasts, and osteocytes. And you will see adipocytes. Adipocytes we're going to see, are filled with a fat vacuole. And so they're really interested in more in filling with fat rather than building up matrix. Okay, so these are the cells that we're going to come in contact with. Now, when we organize connective tissues, it's a bit more complicated than we did for epithelials. We divide them into three groups. We have connective tissue proper. We have connective tissue fluid, or fluid connective tissues, means they're made up of a liquid. and we have connective tissue supportive, or just called supporting connective tissues, and they're things that actually hold you up, okay? So connective tissue proper gets split again into loose and dense. This has to do with the number of fibers in the ground substance. If you have a little bit of fibers and a lot of ground substance, that is a loose connective tissue proper. If you have almost all fibers and very little room for ground substance, you have a dense connective tissue proper. Now on this slide, you see some of them are in red. The ones I have put in red are the ones that you're going to have to know for the lab exam on site. So when we just show you an image of that tissue, you have to be able to identify it and the features listed in the lab book. So I'm trying to make this as easy as possible, okay? So for the loose tissues, you need to know areolar and adipose. You don't need to know reticular for lab, although we're going to discuss it for lecture. For dense tissues, the only one you need to know for lab is dense regular. Now, regular and dense irregular, they're both big concentrations of collagen fibers, and the regular or irregular tells you the direction the fibers are laying. If all the fibers are laying generally the same direction and following a wavy pattern, that's dense regular. That's going to be good for building things that need strength in one direction. So we're going to have tendons and ligaments made out of dense regular. Dense irregular means we stick our collagen fibers all possible directions at once when we need strength in all directions. And someplace we would have dense irregular connective tissue would be under our skin in our dermis, because your skin has to stretch every direction you do. Okay? Now you do not have to identify dense irregular on the lab test. There is also dense elastic. Now, this is different from elastic cartilage, and you always have to say dense elastic or elastic cartilage. You cannot just say elastic or it'll be wrong. Dense elastic means that we have a lot of elastin fibers rather than collagen fibers, and we tend to put these things like the extra stretchy ligaments of the spine, or maybe even in the walls of blood vessels that need to contract and dilate. Okay, so those are the connective tissue propers. We're going to see images in a minute. The connective tissue fluids are blood and lymph, and you are not going to have to know those for the lab exam. We will discuss them in the lecture. And then connective tissue supportive are cartilages and bone. Now, bone was listed in this first lab exam, but I am moving the bone slides to the second lab practical exam because that's all about the skeleton. So yes, you're going to have to know it, but not for the first lab exam, okay? So from the connective tissue supportives, you're going to have to know the difference between the three different cartilages. Okay, so let's get to the images. This is what areolar tissue looks like. Areolar, its name makes you think of airy spaces, lots of empty space. And if you look at this slide, you see that you don't have a lot of fibers. You have more open spaces than you have fibers. Now, this is an up-close view, and the fibers are here. The large pinkish red fibers are your collagen fibers, and the thinner black ones are elastin fibers. If you were to go really close, you'd see these look like little slinkies. And there are even some reticular fibers. It's hard for you to see, but there's a very faint line right here, and that's a reticular fiber. The cells that make these fibers that would be in areolar tissue are fibroblasts. So remember, you need to recognize this on site. You need to be able to identify the elastin fiber and the collagen fiber. Adipose is another name for fat. Now, with adipose tissues, most of the fibers are between the cells, kind of forming a net that they sit in. The cells themselves don't even really look like cells because we take all of the stuff that would be inside the cell in the cytoplasm plus the nucleus, and we shove it over to the side so that the entire middle of the adipocyte, which is the name of this cell, is filled with a fat vacuole. Because the purpose of adipose tissue is to store energy in the form of fat or lipids. It's good for insulation, it's good for energy storage, and it's good for cushioning. So, if you were to be shown this slide, how would you know the difference between this slide and, let's say, simple squamous epithelium? Well, on the simple squamous epithelium, you would have the nuclei of the cells in the centers, But on the adipose slide, notice the nuclei are all shoved into the corners. Okay? All right, so that's adipose tissue. Those are our two loose tissues for the lab test. Our only dense tissue of connective tissue proper for the lab test is dense regular connective tissue. And you notice this wavy pattern, and all of these collagen fibers are following this same wavy pattern that I've drawn here with this red line. So that's what makes this regular. These dark purple spots are the nuclei of the fibroblast cells that are making these fibers. So again, you would find dense regular tissue making up things like ligaments and tendons, where we need our strength to go one direction. Okay, so those are our connective tissue propers for the test. Our connective tissue fluids, remember, will not be on the test, and the only connective tissue supportives that will be are our cartilages. So there are 3 different cartilages. Now, I love cartilage because cartilage is the only tissue that looks back at you. If you look at this image, these kind of look like googly eyes, right? Like those little plastic eyes that you'd see on a stuffed animal. And so if you look in the microscope or look at an image and it looks like you have eyes looking back at you, you are looking at a cartilage. Now your next step is to figure out which cartilage am I looking at. Hyaline cartilage is called that because it has a lot of hyaluronic acid, which draws water in. It makes it slick and slippery and glassy and frictionless. So this is actually our most abundant form of cartilage. We have this on the end of nearly all of our bones in almost all of our joints. If you feel right now the tip of your nose, that's made of hyaline cartilage. Now, cartilage has a thick, firm gel matrix, and it has no blood vessels and no nerves. You cannot feel it when you tear cartilage. It does have a connective tissue membrane around it called a perichondrium. We'll have some nerves and blood vessels. And then all the cells in the matrix are dependent on diffusion of oxygen and nutrients from those blood vessels. So each cell has a little hole in the matrix that it lives in. The name of the hole, and you see this red circle showing you one of the holes, the name of a single one of these holes is lacuna. And if you talk about more than one of these holes, the plural form of lacuna is to add an E, and then you call it either lacunae or lacunae. Either pronunciation is fine. Okay, so that's the hole in the matrix. The cells are all going to be called chondrocytes, and that does not matter which type of cartilage it is. The prefix chondro means cartilage. And so all cartilages will have chondrocytes living in lacunae inside of it, okay? So here is a lacuna. You can see that the nucleus of the lacuna, not lacunae, a chondrocyte. The nucleus of the chondrocyte inside this lacuna is right here. Okay, here's another clear nucleus of a chondrocyte living in a lacuna. Okay, now hyaline cartilage is going to have a hazy background. You don't really see individual collagen fibers, although they are there, but they don't stain darkly. So it's just going to have a pink or purple-ish hazy background around the cells. Okay, so that's cartilage number 1, hyaline cartilage. On the test, you must tell us what kind of cartilage. If you just put cartilage, it will be counted wrong. Okay. Our second kind of cartilage is called elastic cartilage, and we put a lot of elastin fibers in this cartilage. Now, elastin fibers take the stain, when we make a microscope slide, very strongly. And so all of these dark purplish black little webbing looking lines are the elastin fibers, and they're very concentrated around the edges of the lacunae. So my tip for knowing which cartilage picture is for elastic cartilage is the one that looks like the cells are in the middle of a stained glass window. If you've ever gone in a church and seen a stained glass window, there's a thick black layer called leading that's around each pane of glass, each little section. And to me, this dark staining kind of looks like those lead borders on a stained glass window. Now we're still going to have our chondrocytes living in the lacunae. The reason why we know it's elastic cartilage is because of all these extra fibers. Now, where in your body do you have this? You only have it in 2 spots. You have it makes up your outer ear and the epiglottis, which is the flap that goes back and forth between covering your esophagus and your trachea, going back between breathing and swallowing. Now, elastic cartilage is not as strong, but it's much bendier and stretchier than hyaline cartilage. So right now, because I know nobody can see you, put one finger on the end of your nose and feel hyaline cartilage, and then take the other hand and grab and squish on your outer ear, and you can feel the difference between the hyaline cartilage of your nose and the elastic cartilage of your ear. Okay, go ahead and do it. Yeah, you do look a little funny. All right, let's go on to the last cartilage. The last cartilage is called fibrocartilage. Now, all of our pictures of fibrocartilage are actually really misleading because you don't see any fibers. It's called fibrocartilage because it is jam-packed full of collagen fibers normally. I've seen images of this cartilage where it looks like the cells are trying to live in a shag carpet. But our images that we have don't really show the fibers well. This is actually your second strongest tissue. Bone is the very strongest. It's like concrete. And fibrocartilage is the second strongest. And you're going to put fibrocartilage in places where you really would like to have solid bone, but because of movement needs, you can't. So you need something that's at least a little bit flexible. So we're going to put it as a reinforcement in the knee joint. We're going to put it between the front of your two hip bone sections in this area called the symphysis pubis. And you're going to put it between the vertebrae of your spine in the form of intervertebral discs. So that's where it is. Now, this is what it looks like in our images. And my giveaway, my hint, is to me, it stacks up in these long rows, which the other cartilages didn't. And to me, it looks like peas in a pod. And this will always be visible on the lab test if we're going to ask you a piece of fibrocartilage. If I showed you just this side, that looks just like hyaline cartilage. That wouldn't be fair, would it? So I will make sure that the images used for fibrocartilage all have the peas in the pod configuration. Okay, so those are your connective tissues. So now with the epithelial tissues for lab, you have simple squamous, simple cuboidal, simple columnar, stratified squamous. That's 4. Then the connective tissues, you have areolar, adipose, dense regular connective tissue, hyaline cartilage, elastic cartilage, and fibrocartilage. So that's a total of 6. So you have 10 total tissues that you need to be able to know on site what tissue it is, what cells are there, and any other features listed in your lab book. Okay, guys, I hope this helps you out. Happy studying and good luck on the lab test.